Alright, hello everyone, and welcome to my garden. So I'm going to go over some igneous rocks here. I've well sprayed up with mosquito repellent, so hopefully I will not get bitten because the mosquitoes are super bad here in my yard. Alright, so normally what we would do in class is we would really work on the identification of rocks. Because you do not have rock kits at your house, and working from photographs is doable but not great. I would much rather you working with hand samples. So instead of working on identification, we are going to work instead on interpretation and understanding that if you notice a particular rock in the field, what does that tell you about the history of that area? What kind of plate boundary? What kind of activity, igneous activity was occurring at that particular spot? So I'm going to start. Well, first, before we start, if you don't have it in front of you, there is a handout that has the rocks kind of organized according to texture and mineral composition. So that if you don't have a handout, go ahead and pause the video, and then go and either pull it up on your phone, your computer, whatever it is you're using, or print it out, or sketch it on a piece of paper, whatever you have, just so you have it to reference, because I will be referring to that that handout, that organization of the rocks, and so it'll be much more useful for you if you have that handy. Okay, so if you look at the handout, there is on the left-hand side, there is a column that says the texture. So we're going to focus first on fine and coarse grain texture. So I'm going to start with that, and then we'll go on to other parts. So if we look at, say, this granite here, this granite, and I'm actually going to show close-ups of this because you're really far away from me right now, and it's really hard to get close. So if we look at this, even from a distance, you can see that it's speckled compared to, say, this rock. So if we have these two rocks together, this one looks speckled, you see multicolors. This one looks pretty much probably uniform pink from your distance there. You can probably see that this one is speckled. This one here is speckled. But this one is kind of a uniform gray-green. This one, it starts to get a little bit harder to see the speckles in this one, but if I turn it, perhaps in the light, you can see the light reflecting off of those crystal faces. So that tells me that those are large crystals, they're visible crystals. Whereas if I pick up this one, it's pretty much a uniform dark green-black rock. And then this one here, hopefully you can see that it is also speckled. And I will have images that you can see a little bit closer up, as well as I will have a video that shows them close up, so you can see them a little bit better. So that is the difference between fine grain and coarse grain texture. Coarse grain texture means that the crystals are all larger than 1 millimeter, or the shorthand is they're visible. And then fine grain is the grains are 1 millimeter or smaller, or not visible. So you either have very small grains or large enough grains to see and potentially identify. For example, this particular one, the pink, is potassium feldspar, the orthoclase or K-spar. There's some little chunks of gray, what looks like gray glass in here, that's quartz. The black parts are either hornblende and or biotite. So I can see those minerals, I can identify them. But if I pick up this one, it has the exact same minerals, but I can't really identify them. They're too small. Most of the rock is so tiny, I cannot see anything in it. So that's the difference between coarse-grained and fine-grained. And that crystal size between the coarse, the greater than 1 millimeter, or less than 1 millimeter or less, is dependent upon rate of cooling. So we use crystal size, that texture, of coarse or fine grain to identify whether a rock cooled slowly underground or rapidly at or near the surface, within a kilometer of the surface. In order for crystals to grow fairly large, they have to have a lot of time. They have to have time for those ions to make it through and to find each other and organize into their crystal structure. And then they grow together and form a solid rock. So they start from a liquid, or rarely is magma actually fully liquid. It's usually a mixture of solids, liquids, and gases, and those solids can be more or less depending on the temperature of the magma and its location in the crust, whether it's down low or up high. So there's a lot of different factors that can affect how much solid, how much liquid, how much gas. But oftentimes magmas may be a little bit more like a slushy than, say, glass of milk, for example. Or maybe they're more like soup, where it's got hard bits or solid bits in it, as well as, like a chicken noodle soup. So it's more like a mixture of solid and liquid, or it's an awful lot of solid mixed in with a little bit of liquid. So in order for us to get coarse-grained rocks, or for those to form from a magma, there has to be a lot of time. And when I say slow cooling, I don't mean like a few hours, few days, few weeks, few years. I'm talking like millions of years, 10 million years to cool. Whereas the fast, to get the small crystals, it crystallizes very quickly, and that can happen literally at or near the surface. So if it pours out onto the surface as lava flow, well, then it's going to cool pretty daggone rapidly, because it's going from, this rock in particular, maybe 600 degrees Celsius down to, well, whatever temperature it is outside. Say if it's on the Mount St. Helens or something, up at the top of Mount St. Helens, it's below freezing. So you're looking at a major change in temperature, so of course it's going to cool relatively quickly. So that forms small crystals. Big crystals, more time. Small crystals, very little time. There is a limit to how big those crystals can get while cooling slowly. So to get the really massive crystals, then sometimes there are pegmatites, which is a different texture, a pegmatitic texture, really super large crystals, anything larger than 5 centimeters. So you think about 5 centimeters is, let's see, there's 1 centimeter. So 5 centimeters is maybe this much. So when you're talking about the majority of the crystals being 5 centimeters or greater, then it doesn't mean that it's just super slow cooling. That's actually very, very near the end of the crystallization of a magma, when there's a lot of water that gets released into the magma because it doesn't go into all the minerals, and that water makes it kind of easier for the ions to travel through the liquid, and therefore they will meet up together and make even larger crystals. And so those are pegmatites. They get really, there's actually some pegmatites where feldspars can be large as a house, and the biotite crystals, which are normally very small, could be the size of your kitchen table. Books, stacks of sheets, several feet thick, and just the size of a large kitchen table. So those are, normally they're like teeny tiny little things. So those are unusual and very rare, but very important. So when we find those in somewhere, then those are usually mining or ore quality, and they'll be mined for the either just for the mineral or for the ions that are in the mineral, and those are useful. So that's the difference between coarse and fine grain. Coarse grain slow cooling, underground, deep underground, deeper than a kilometer, maybe as far down as 5 or 6 kilometers. So we call those plutonic rocks because they're cool. They cool underground, and if you where you get the word plutonic from the I think it's the Roman god. I always get them mixed up, but maybe it's the Greek god. Anyway, the god of the underworld, who's Pluto. So plutonic is taken from that. The fast cooling are volcanic rocks, and volcanic rocks are taken from the god of fire, or the god of volcano, blacksmith to the gods Vulcan. So that's why I think they might be Roman. Because Vulcan's blacksmith shop was, or his forge was in Mount Vesuvius, which of course is in Italy. Alright, so that's the beginning, first part of the rock video. So that is fine versus coarse grain texture.